what is mesh analysis? Or what is its significance in circuit analysis? Any idea? Alright. In fact, in circuit analysis, simple circuits can be analyzed by using basic tools like Ohm's law, KVL, and KCL. But the analysis of complex circuits using these basic tools are somewhat difficult. That's why we go for techniques like mesh analysis and nodal analysis, which help us to reduce the complexity of a given network and find desired current or voltage as whatever is required. Okay guys, it's me Abhisha. You are watching me on our channel Crack Easy, the place to learn how to crack easy exams. Have you subscribed this channel? If you have, please do it as early as possible. Today I'm here with a session on mesh analysis. Stay tuned to the lesson as I'm going to share some tips on how to avoid mistakes while applying mesh analysis in a network. What is mesh analysis? It's a circuit analysis technique based on Kirchhoff's voltage law, KVL. Is there anyone who doesn't know what is KVL and how to write KVL equation of a closed network loop? Then you watch my session on KVL. The link of that video is given in the description box. I think we can start today's session now. Mesh analysis. It's nothing but a circuit analysis technique based on Kirchhoff's voltage law, KVL, which help us to find solution of a network. In fact, there is one more technique, nodal analysis based on KCL. The suitability of mesh analysis or nodal analysis to a particular network depends mainly on number of voltage sources and current sources present in that network. If a network has large number of voltage sources, then it is better to use mesh analysis. On the other hand, nodal analysis is preferable to a network with large number of current sources. In this session, we will be focusing only on mesh analysis. I'll definitely do another video on nodal analysis. Now, let's have a look at some basic concepts related to mesh analysis. The first thing I want to share about mesh analysis is that it is applicable only to planar networks. What is planar networks? Can anybody tell me? It's nothing but a network which can be drawn on a plane surface without any crossovers. Now have a look at this network. Is it planar? Is there any crossovers present in this network? No. So it is a planar network and we can use mesh analysis to find solution of this particular network. What about this network? Is it planar? Is there any crossovers present in this network? You can see a crossover here. Hence, it is a non-planar network and we cannot use mesh analysis to find solution of this particular network. So we can conclude that before applying mesh analysis to a particular network, we should make sure that it's a planar network. Got it? Now let's see some more basic concepts related to mesh analysis. Do you know what is a mesh? It's nothing but a loop in a network that doesn't contain any other loops within it. And the current flowing around a mesh is defined as mesh current. Got it? Let me now take you to the procedure or steps to be followed for performing mesh analysis in a network. In first step, we are supposed to check whether the network is planar or not. If it is planar, we can use mesh analysis to find its solution. On the other hand, if it is not planar, we should go for some other circuit analysis technique. Then we have to identify all meshes present in the network and label each mesh current. It is better to label all mesh currents in clockwise direction. It will help us to simplify the mathematical analysis. Next, we have to indicate the polarities of voltage drops across each resistor. It should be marked according to the direction of assumed mesh currents. Finally, apply KVL in each mesh. As you know, KVL can be applied either in clockwise direction or in anti-clockwise direction. It is better to apply KVL in the direction of assumed mesh current. It will help to simplify mathematical analysis. One more thing you should understand before applying mesh analysis to a network. Suppose we have a resistor that is common to two meshes, so that two mesh currents are flowing through that. When we write KVL equation in a particular mesh, the total current through the common resistor should be taken as assumed mesh current in which KVL is applied plus assumed mesh current of the adjacent mesh in same direction minus assumed mesh current of the adjacent mesh in opposite direction. This last point may be confusing. Don't worry, you will get a clear picture when we solve problems. So, moving on to problems. Determine the current flowing through resistors in the figure using mesh analysis. Network is given here. Here we have two voltage sources, 42 volt and 10 volts, and three resistors. The current through these three resistors are to be determined using mesh analysis. As I told you earlier, mesh analysis is applicable only to planar networks. In first step, we are supposed to check whether this network is planar or not. How can we check? A network is said to be planar if it can be drawn on a plane surface without any crossovers. Can you see any crossovers present in this network? No, so we can say that it's a planar network. Step 1. Circuit is planar. In step 2, what we are supposed to do? We are supposed to identify all meshes present in the network and label all mesh currents. When we scrutinize the network, it is clear that there are two meshes. This is our first mesh and this is our second mesh. Let us label I1 as mesh current in first mesh in clockwise direction and I2 as mesh current in second mesh in clockwise direction. What we are supposed to do next? We are supposed to mark polarities of voltage drop across each resistor. Here we have two mesh currents I1 and I2. Let us first focus on the polarities of voltage drop developed by mesh current I1. You can see this I1 flows through this 6 ohm resistor and through this 3 ohm resistor. The current entering terminal of a resistor should be marked as positive polarity of the voltage drop developed by it. Got it? I repeat, the current entering terminal of a resistor should be marked as positive polarity of the voltage drop developed by it. When you look at this 6 ohm, you can see current I1 enters 6 ohm at this terminal. So it should be marked as positive and this one as negative. On the other hand, current I1 enters this 3 ohm resistor at this terminal. So we mark it as positive and other terminal as negative. Moving forward to current I2. Current I2 flows through this 3 ohm and through this 4 ohm. It enters 3 ohm at this terminal. So we mark it as positive and other terminal as negative. Then it enters 4 ohm at the left. So we mark it as positive and other terminal as negative. Alright. Our next task is to write KVL in both of these loops. So this is the network to be analyzed. First we are going to write KVL in this loop in clockwise direction. Starting at this point, first we observe this voltage source with the polarity mark in the order minus plus. So we can start our KVL equation with the minus 42. Then the voltage drop across this 6 ohm. As you know, voltage drop across a resistor can be mathematically expressed as the product of resistance value and current. Here I1 is the current flowing through the 6 ohm. Correspondingly, the voltage drop across it can be expressed as I1 into 6. Based on polarity mark, we add a term 6I1 to KVL equation. Finally, the voltage drop across this 3 ohm. You can see this 3 ohm resistor is common to both meshes, and two mesh currents I1 and I2 are flowing through this 3 ohm in opposite direction. As I said to you earlier, when there is a resistor common to two meshes, the total current through that common resistor should be taken as assumed current in which KVL is applying plus assumed current of the adjacent mesh in same direction minus assumed current of the adjacent mesh in opposite direction. Here we are writing KVL in first mesh and I1 and I2 are flowing in opposite direction. Correspondingly, the total current through this 3 ohm becomes I1 minus I2 and a voltage drop 3 into I1 minus I2. And this algebraic sum of voltage drops around first mesh is equal to 0. Alright? By rearranging this equation, we get 9I1 minus 3I2 is equal to 42, which is labeled as equation number 1. Next, we are going to write KVL in second mesh. Starting at this point, first we observe this 3 ohm resistor. The total current through this 3 ohm should be taken as I2 minus I1 since we are writing KVL in second mesh. Correspondingly, a voltage drop 3 into I2 minus I1 develops across it. So, we start our KVL equation with 3 into I2 minus I1. Then the voltage drop across this 4 ohm, which is nothing but 4 into I2. Finally, this 10 volt voltage source with the polarity mark in the order minus plus. Correspondingly, we add a term minus 10 and this is equal to 0. By rearranging this equation, we get minus 3I1 plus 7I2 is equal to 10, which is labeled as equation number 2. When we solve equation 1 and 2, we get I1 is equal to 6 amperes and I2 is equal to 4 amperes. Hope you remember, in our question we are asked to find out current through 3 resistors, 6 ohm, 4 ohm and 3 ohm. Current through 6 ohm resistor I1 is obtained as 6 amperes. Current through 4 ohm resistor I2 is obtained as 4 amperes. Finally, current through 3 ohm in downward direction I1 minus I2 is obtained as 2 amperes. Hope you understood this problem perfectly. So we are at the end of this session. If you have any doubts, please do let me know in the comment section. Thanks for watching. Thank you.